All right. It is Monday. Happy Monday, everyone. August 30th, 2021. Welcome to my math class. Aren't you happy to be here? Yes? Good. Good. I'm glad to hear everyone say yes. Makes me very happy. Hey, seriously. We have already been working on the review slide. I've been around to do a check for the class. And here's what I found out. Every single person in my class drew a complete rectangle. You drew a rectangle. Rectangles look like this, right? Everybody drew a rectangle. Most everyone had a side length of 2. So one of your sides had a 2 on the side, right? And then most people gave their other side a number. So let's go ahead and get a rectangle going down here. We have a side length of 2. Get rid of this. We have a side length of 2 here. And now what we need to do is we need to get a number into this purple circle. We need to label our other side. So here is what I want you to consider. When you are labeling this other side, think about what is reasonable. What is going to be reasonable? So, if I want my answer to make sense, and I want my model to look accurate, what is one number I cannot put in this circle? Tucker.
1.
Why not, Tucker? I like the number 1. That's rude. You're not very nice to the number 1.
Oh, if you look at number 2, it's way smaller.
2 is this big. Are you listening to me online? Give me a thumbs up if you're hearing what I'm saying. Especially you, JP. You hearing me? Yeah. This line here is a short line. This line here is a long line. So this number is a 2. This number cannot be smaller. It cannot be a smaller number. That's not reasonable. Say that with me. That's not reasonable. It doesn't make sense. It's not reasonable. So, it's not going to be a 1. What else is it not going to be? Annabelle.
2.
It can't be 2. Why can it not be 2? Jackson, turn your mic on and talk to me about why it can't be 2.
It's because that the lines are equal, so and one side's 2. So if the other longer line is 2, then it wouldn't make sense.
Thank you. What a beautiful explanation. Say it with me. That's not reasonable. That's not reasonable. It cannot be 2. What other number can it pretty much not be? Remington.
0.
That wasn't what I was thinking, but you're right. It cannot be 0 because 0 would be nothing, right? It can't be 0. What else can it not be? What else can it not be, Cameron?
3.
It can't be a 3. Why can it not be a 3, Cameron?
Because it has to be just a little bit bigger.
That's right. This 2 is this long. And if it was going to 3, what do you think? It'd be like, maybe like that?
Yeah.
Ish, right? It can't be 3. Say it with me. That's not reasonable. It cannot be 3. What do you think it could be? Let's get some answers here. Izzy, what can it be?
Maybe like a little bit over a 4 or like a 5, maybe.
Maybe like a 5. Okay? Who else has a different idea? What do you think? What could it maybe be? What could it maybe be? Brentley? Yes.
6.
Maybe 6. Sure. Gabe?
14.
Okay. Gabe?
I wrote a 14.
Yours is a 14. That's okay. Gabe, look at my model. if this is 2, Gabe, is this one here going to be 14? Is that reasonable?
I wrote 2 and 14.
I know, but look at my model up here. Is this reasonable? If this is a 2, you think it's reasonable for this to be 14? Ah, man, my model's not the same as yours. Doggone it. What's another reasonable number? Hey, do you think we might be getting close to running out of reasonable numbers? We're getting pretty close, aren't we? What do we got here, Gracie?
I was thinking a 4.
A 4?
Because when you drew the 3, it looked like, since you were doing the things, it looked like it would be, if you did one more. Like
Okay, sure. I can take it. That's way more reasonable than 1, right? Way more reasonable than 27, right?
I don't see that being 27. That was said 27.
I know, but I'm just saying, if somebody thought 27 is
No.
unreasonable. Cole, what? One more.
7.
Maybe 7. Maybe. You think it's going to be 8? No. 9? No. We got like 4 numbers to play with here, okay? We're going to go with 5. Let's just go with 5. Whoopsie. Let's go with 5. So here's our 5. So we have now labeled both sides. Most everyone did these first parts. This is where the wheels fall off the cart right here. What are the factors of my rectangle here? What are my factors, Chloe? 10, she says. Is 10 the factors? What is 10? What is 10?
That's the,
What's 10?
the answer.
Okay. The answer. What else would we call that?
The area.
The area. What else would we call that?
The factor.
10 is not a factor. 10 is our product, our area, our answer, our multiple. 10 is our multiple. I want to know what the factors are here. Gracie?
2 and 5.
2 and 5 are our factors. The factors are the side lengths of your rectangle. And you need to remember that for today's lesson. You need to remember that your factors are the side lengths, because factors are what we're going to be talking about. So, as we go through our teaching, learning journey, I want you to know that when I'm standing up here teaching, I am being intentional with what we're talking about. And I want you to know what my intentions are. My intentions today are that we are learning whether numbers are prime or composite. So we're going to learn what these numbers mean, what these words mean, And then, how am I going to decide whether or not you are successful? How am I going to decide whether or not you are successful in the lesson? I want to know, can you draw the rectangle of a prime number? Can you draw the rectangle of a composite number? This is my success criteria. If you can do these 2 things, then we've been successful together. If you cannot do these 2 things, then we need to go back and revisit. Right? Okay. You guys can close your Chromebooks. Oh. And I want you to, let's see. Table 1, you're going to be working in a group of 3. Table 2, you're going to be working in a group of 3. Table 3, you 2 are together. Table 4, you 2 are together. Table 5, you're in a group of 3, and you're on your own. So here's what you're going to do. You are going to get the tiles out of your caddy. You have a bag. You need 1 bag per table. You only need 1 bag per table. So you are going to get a bag out. Take 1 set of cards, only the green cards, with your table. I want you to take 2 minutes. Take 2 minutes to sort the cards. Here, Jackson, you can talk to Chloe. There you go. Turn your microphone on, Jackson, and talk to Chloe.
All right. I don't know what we're working with. I know what we're working with.
Jackson, you're looking at the cards on the screen. The cards on the screen are the same cards she has in her hand. And so you're going to look at those cards, and you guys are going to sort them together. Get to work. Sort them together.
So, what do you think is gonna go first?
Probably maybe B and maybe B and A.
Okay, let me find B first.
Class?
Yes.
I'll tell you right now. It is not by letter. Do not sort them by letter.
So, we're not gonna use these together because she just said we're not gonna do A, B, and like that, A, B, C. So they're gonna go. I'm gonna guess they're gonna go by area.
Area or like length? I'm not sure. It's probably
Area. Probably area.
But if we're talking area, then
Because some of them do have area. See,
then
that one does.
Then the one at the top corner, then the one at the other top.
A or F.
And A, F, C, and H. All of those are going to go together because they do not have an area.
So A, F, and C. Okay. Yeah, you're right. They don't have an area.
And H.
What?
And H. So F, A, C, H.
Where? What? What do you mean?
Well, instead of having just A, C, and F, you're also going to get H.
H?
So A, C, F, H.
So then what are we going to do with these? I have them in a little order. Kind of.
And the two D and B, those might go together since they both their ending is a
Well, let's count them first. So they might be the same area. They might not. So you count on your end and I'll count on mine. Okay.
Class?
Yes.
Who had some ideas? Who had some ideas on how to sort your cards?
Jackson had an idea about how she did. He said these ones were going to be sorted out because they don't have any area in the side.
Okay, so Jackson had the idea that all of the ones that didn't have boxes on the inside, all the ones that didn't have the boxes already put on the inside would go together. Who else had that idea? Yeah, sure. Other ideas? What else do you think? Izzy?
I said maybe for these ones, times them and see if that number matched up with any of the boxes.
Okay, did you find any that match?
We're still looking.
Still looking. Annabelle.
By area.
Annabelle wants to sort them by area. Interesting. So, if we sort them by area, what would the first area be? What do you want first, Annabelle?
7.
This one here, letter G?
Yeah.
7. Does 7 have any matches? If we're going to sort it by area, does 7 have any matches? 7 doesn't have any matches. So what else would we sort it by? Someone find the area of another one of these boxes. Cole?
Oh, I forgot it.
Tucker?
On D, it's 16.
D is 16.
It's 18.
Okay. D is 18. Izzy?
On letter F, we got 36.
Okay. Ladies and gentlemen, look at what I'm doing. I'm sorting my cards as we go. So as you go, those of you that have actual cards, you should be sorting them as well. Chloe.
So I found out that D and C have the same area.
D and C have the same area. What is their area?
They're both 18.
They're both 18. Okay. What else you got? We got H, E, A, and B. I got some people that aren't participating with their team. So you need to jump in and participate with your team.
I'm still thinking about what we can do with the
Huh?
I'm still thinking about
Huh?
I'm still thinking about which one we should count the area.
Yeah, you can't do that from back there. You need to be with your team, figuring out which one. We need to find the area of H, E, B, and A. Jackson, you do A right here. Hold on. There you go. Nice and big for you. Find the area of A.
That one.
What do you got, Tucker?
It's E and F together. E and F. They're both 12.
12? There's your card back, Jackson. Sorry. Chloe, what do you got? Hold on. Jackson's working on the area for A. What do you got, Brentley? H and what? What is it?
I might know it for A.
Okay, hold on. 36 for H and B. What color do you want it to go in? Blue, orange, purple, or pink? Purple. What do you got here, Jackson?
Maybe for A, it might be 24.
Chloe, Jackson thinks A is 24. Is that what you think? Yeah? Which box is it going to go in? Blue, orange, purple, or pink? You.
Maybe blue.
Well, what's blue, Jackson? What's the area of these here?
Yeah. So it's not gonna be in blue. So
Huh?
it's not gonna be in blue. So
Why is it not going to be in blue? What's the area of the blue rectangles?
18.
Look at. Yes.
18.
So is your 24 going to go in the blue?
No.
No. Hey, Brentley, are you sure you want these two here to be in this purple box? What are the area of these two? Cole, what's the area of these two? Huh? 36. Do we already have a box that has 36? What's the area of this one? Huh?
36.
36. Where do you want these to go, Brentley? Yeah, let's put these down here.
So then the 24 might go in the purple box.
Good job, Jackson. So Jackson wants 24 in this purple box. Are we cool with that? What are we going to do with this guy? Here he is, nice and big. How much is this guy? Gracie?
24.
He's also going to go in purple.
Good job, Jackson. He's 24 as well. So, here we are.
Okay.
We're all settled here, right? So, we have here for blue. Here for blue. What's our number here for blue? Huh? What's the number for blue? Anybody? 18. What's the number for orange? Brentley, what's the number for orange?
36.
36. What's the number for purple? Chloe? 24. And what's the number for pink? Gracie? 7. Here are our sorted cards. We have the D and C together as 18. And how did we sort these cards? By
Number.
Area. Area. Very good. We have these 2 cards together for 18. We have these 3 cards here together for 36. You guys tracking with me? We've got these 2 cards together for 24. And then we've got this 1 card all alone here for number 7. Now, I have a job for you. Here is a list. 36 area, 18 area, 24 and 7. Here is a list of all the different areas we made with these cards, right? Can you draw another box for each one of these areas? 18, 36, 24, and 7 in your Cactus notebook underneath the classwork line. Can you draw another box for these? Jackson, I want you to work with Chloe for a second. Just one more box for each one. I just want one more. So draw your classwork line. Can you draw one more box for these areas?
So,
Nice. Very good.
So yes or
That's right.
no?
Draw it. Draw
I
it.
think yes, but so it's like we have to agree on something.
Very good.
I mean, I don't know how because they're all different numbers. So,
Well, they're separated to one like that, and they're the same number.
no, but how are we gonna put them in one box?
Well,
Because they're all different numbers. So,
so no. You think no? I mean, I do agree, but
Yes, please work with your team.
I do agree, but I think we should try to at least, but
yeah. Like maybe we could make a box and call it any area over 6, and it could be all those.
You don't have to draw the stuff inside of it. You can just label the outside of the box if you know you're right.
So we're gonna draw a box, right? And then we're gonna do 18 and then 36 and then 24
You
and
have
7.
3 minutes to work with your team. That's not very long. Up here on the board is what we already have. So for 36, don't draw a box that has a 6 and a 6. We already have that. Something we don't have for 36. Something we don't have.
We can make the area 36.
Well, we have all the other.
Yeah, you are.
I know we could do that for all the others.
You're a good partner there, don't you?
You can put them all in their individual.
So you're saying that the area is 36 to all.
So we can make it where the box that it is so it's the area is 36. And for 7 the area is 7 and 24 and then 18.
Yeah, we can do any of those numbers. We can do any of them. Now I was kind of confused, but now I know. So we'll make it 36 and then we'll do
7.
we'll do so what do you want to do put out on the outside? We can do 6 and 6 because that's what you just said that because that's already something that we have.
Can we do 4 and 8?
So
Wait, do they already have that? Nope, that's for 9.
so that wouldn't
Yeah, I think we could. Yeah, we could do that.
you can.
And then for 7 would be 2
So
and
what are we going to make it? Are we going to go stick with 36 or are we going to go to 24? Because I want to go.
let's go to 24.
Okay, because that's a little bit more easier. So you can do 7. You can do 7 times. No, you can't do that.
We could do 7 times 3.
7 times 3.
Mm-hmm.
7 times 3 is 21.
Dang it.
So wait, we could do 3 times 8.
We already got 3
We already
times
have
8
that.
up there.
Hey.
Class?
Yes.
All right, let's look at this together. Huh? Let's look at this together. Okay. So, this is how we sorted our cards if you look at the board. For 36 area, we had 6 times 6 was 36, 3 times 12, 9 times 4. What are we missing here? What'd you get, Tucker? Did you get 1 for 36?
No, I only got 1 for 8.
1 times
Anybody get 1 for 36?
1 times 36.
1 times 36. Very good. So we could take this and turn this into a 1. Turn this into a 36. Very good. What did someone else get somewhere else? What'd you get, Remington?
On the 18 one, you can have 1 times 18.
Yeah, it's right here, dude.
It has it up there, and I
What?
can't see it up there.
It's right here. Were you looking at your cards? Please don't say that.
They were looking at them, and
Please,
I was just
hey.
helping them sort it.
Please don't say that word.
I was just pushing cards to be sorted too.
We got 1 times 18. What do we need? What else you got, Cole?
2 times
2 times 9. Good. We can put a 2 here and a 9 here. Anybody get anything for 24? Cameron?
2 times 5.
2 times 12. Very good. 2 times 12. So we filled out these lines, but look here. We got 2 more. What else can we do for 24? What are we missing? Remington. 1 times 24. Very good.
Yes.
1 times 24. I need one more here for 36. Who can figure it out? Tucker? Tucker, think about it. Tucker can figure it out on the fly. 36. You guys are doing a good job letting him think. You got it, Cole? Already got 3 and 12, brother. I want this one right here. What do you got, Tucker? What do you got, Cole? 2 and what? 2 and what gives me 36? Cole? Gracie?
I heard you said, well, you partly said it's 18.
18. I said it.
You partly,
I accidentally said it out loud.
you partly said it and then I know.
I know, I messed up. So let me ask you a question. Let's look at this little number 7 over here. Let's look at this dude. 1,
He's just all lonely.
2, 3, 4, 5, 6, 7. So here's my box, my rectangle, right? Is there any way for me to rearrange these 7 tiles to put a number here? Think about it with your table for one quick second. Hello. Okay.
Seven areas.
Class?
Yes.
Who has an idea how you want to arrange these blocks? Alea. Okay, we could do that. So watch me. We could do this, a little spinneroonie action right here, right? Right, we could do that. Is that going to change my numbers?
No.
I still got a 1 and a 7, right? Okay, so thanks. Good job, Jackson. That's not going to change. How else can I put these blocks? Tucker,
Oh. 4.5 and 4.5.
am I allowed to split them in half?
That's the only
Nope.
thing I can think of. Because it's not an odd number. You can't split it in half.
You can't split it in half, so we can't do. So Tucker is hung up on rows of 2. He wants to do rows of 2. We can't do that. That's not going to work.
Because you're not even.
That's right.
They're not even.
Can we do rows of 3?
Yeah. No.
No.
Can't do rows of 4.
Can't do rows of 4. Can we do any other? Can we do it any other way? No. That means this number is called a prime number. This number here, right here, 7 area, is called a prime number. That means that it can only have one complete rectangle. Are we listening? Shirley, are you sure? It can only have one complete rectangle. Look at all these areas over here. Look over here at these here. Look how many this one makes. That makes a bunch, right? That makes a bunch. This one here makes a bunch. But this one only makes one. These three here are called composite numbers because you can compose a whole bunch of different boxes with these numbers. 7 is called prime. So let's move these over. Let's move these into the number they go with. The number 24. Is the number 24 prime or composite? Composite. Because we can compose a bunch of different complete rectangles if we have 24 tiles, correct? What about 18? Prime or composite? Composite. Yes, sir?
I have a question of all of them. Can you go back to where it shows all the numbers?
Yep.
36 is odd. 18 is odd.
Is what?
Is odd.
Even.
Well, even.
Yeah.
Big brain powers.
It's odd, but 7 is even.
Odd. 18, 36, and 24 are even. 7 is odd.
Yeah, you can't.
Good.
Odd numbers.
Now, you can some of them, because what about 21? Watch this.
Yeah.
Look here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. This is 21. And did I make a complete box here, Tucker?
Yeah.
Yes. So it's not odd numbers is a good idea, but it's not always only odd numbers.
But
Most of your prime numbers are going to be odd. Yes. All right, let's go back over here. 36. Look here and see how this word composite sort of kind of has the word. Oh, what's going on here? This should be, because I'm doing it wrong. Right here it is. There we go. See how it kind of has that word compose in it? You can compose a bunch of different boxes out of these numbers. 36, prime or composite?
Composite.
Yep. What about 7?
Prime.
Prime. Now, I have a poster in my room. It's right up here behind these clipboards. And it says prime numbers, 1 and myself. Look at this number 5 right here. He's saying my factors, easy. It's 1 and me. That's it. Prime numbers only have the factors of 1 and themselves. So the factors for 5 are 1 times 5. I'm going to show you some other prime numbers. 1. What's the factors for 1? Chloe? Well, that'd be 0. Gracie? 1 times 1. What about 7? What are the factors for 7? Cameron? 1 and 7. What about 5? We already talked about. What about 13? 13, Tucker?
1 and 13.
1 and 13. Do you see a pattern here? What about 41, Remington?
41.
Yeah.
I see the pattern.
83. What pattern do you see, Jackson?
It's all times 1.
1 times themselves, right? Good. What else we got here? What are the factors, Brentley?
11 times 1.
What about for 3? What are the factors for 3, JC? What have we been talking about? 1 and myself. Help her, Jaden. What's the factors for 3? 1 and 1 times 2 is 2. 1 times what equals 3? 3. Oh, look at that one. What was that one? Gabe? This one, next one here.
61.
And what are the factors for 61? 1 and 61. Ooh, 17. 17, Alea. Good. Very good. So tomorrow I'm going to ask you to draw a rectangle of a prime number and to draw a rectangle of a composite number. And when you come in, that's how I'm going to decide whether our lesson was successful. Okay? I'm going to go ahead and shut off this recording. You guys did a great job.
Wait. So
I'm not going to close out of the meet. I'm just going to turn off the recording. You're okay.